My name is Kevin Mamajek. I'm here in this Tridium talk to talk about how tagging can enable analytics. Before we do that, I have some housekeeping, which is questions should be submitted through the QA tab, and then we can kind of keep a log of those and post the answers if we can't get to them in this session. We are recording this session, and we'll post the recording within a few hours. It just has to do some conversion. I plan on sharing the example station most likely in about 2 weeks. I'm working on it. I'm completely changing the UI, which you'll see in this webinar, but I'll get that posted for you. What we do is we'll list a link under the resources, under events, under 2019 Tridium Talks, and you'll find when this posts and the station is there as well, once we get that posted. Just for reference, analytics, we do have some online education and in-person training. So take a look at the training schedule. This is a real quick showing you that we have some June, July, and September training. Actually, wait, you have to go to Australia and China for some of those. So look for the American ones, September and November and June. So take a look at those. Best web fonts, I put this on here because I am frantically going through my station and making them HTML friendly fonts. So I'm just telling you now, when you see another font and it's not nice and pristine, I know I'm trying to get everything to Arial as quickly as possible. So with that, let's take a look at the basics of tagging. So here we have a number, 72. We have no idea what that number is, right? We don't know what it means. We don't know what the scale is. So it could be anything, right? It could be the sum of 4 consecutive primes. It could be the place of an exterior, the plane of an exterior angle of a pentagon, which measures 72 degrees each. It could be the atomic number of hafnium, Messier object. It could be the registry of a U.S. Navy nuclear aircraft carrier. It could be 18 holes of golf. It could be the spaces in Parcheesi. You get the point, right? I don't know what that 72 means unless I have context, right? Or it could be the temperature of a room, right? But it has to have context. So what is that 72? Tagging is essentially how we're going to give that context. We're going to tell that 72 and we're going to tag it and say, hey, you're a temperature, your room temperature, maybe your return temperature, a supply, an outside temperature. Tagging gives it the context so that we know what we can do. Once we have these identified and tagged, then we can start to use that in Niagara in forms of hierarchies or analytics. So you got to tag before you can analyze. You got to give it context. So here are some example tags where I'm using the Haystack tagging dictionary. So I can tag a site as site ref, equipment ref. I could tag it as an RTU, a temperature, a zone, a VAV zone. I can give context to that point. And the tags is essentially how we give that data inside of Niagara context. But wait, tagging also helps you with hierarchies, right? So here I've got a series of sites and their JACEs, and just by applying the geostate and the geocity tags, I can then give those contexts so that I could display them in a hierarchy, such as North Carolina, the city, Charlotte, and that particular JACE. So it organizes my hierarchy, and it's very easy to do that hierarchy, and we can take a look at that, which is pretty simple, right? I'm just using a group level for the state, a group level for the city, and then a device level to list anything underneath that, okay? So once I started to understand tags, I realized those are great shortcuts to doing some of these hierarchies. And then, of course, when you look at essentially, some of the capabilities of the hierarchy, right? So here's just an analytic chart, which is a module that's new to 2.1. It allows you to use the hierarchies then to drag out your data right? So I can drag out was theory 1, 2, 3, 4, and then I can chart, right? So I didn't have to worry about where was the energy meter inside building 1. I just drag out that hierarchy node and then it goes to the relative data using the HS power tag. So that again is another feature that if I start to tag, I can start to use them as hierarchies and then I can start to look at them in the analytics. So tagging basics, there's a direct tag, right? I can go and pick a point here and then I can apply these tags, and these are direct. I'm just typing them from the haystack. So I put HS sensor and then there's another direct tag called A:(A). But I had to physically go to that point and tag it. And that can be tedious, right? That's essentially going to every point and then trying to put the context in of where it's at. So I know none of you want to do this. And this is anytime I talk about tagging, this is what people think you have to do. So there's another methodology of tagging that implies these tags. And so you'll see here, there's a bunch of implied tags for this particular control point, which is room humidity. And we'll see how I can use a rule, a tag rule, to actually apply that automatically. So I don't have to worry about tagging. I can create the rule and then it will automatically go and tag my points as I create them. Okay, so any takeaway here is I need you guys to focus on rules because it will make your life so much easier. So with that, I'll kind of jump into Workbench and kind of show you how we can do this. So let's take a look at the tag dictionary service. So in this service, I've got several tags. I've got the standard Niagara dictionary. I've added the haystack dictionary. So how you do that, right, is I can go in here and open up haystack and it will then show me that there's a haystack library that I can drop in. I've already dropped it in. So if we look at the haystack library, we can see that there's a bunch of definitions, right? These are the direct tags. And then you'll see that there are some tag rules that actually work on my behalf, right? So here we can see a device, right? We can see that it puts a device marker on there, that rule. It's a condition where it's looking for a driver device, so it automatically applies that. So just by adding the haystack library, tagging library, I can automatically get these haystack components tagged automatically to my system, okay? So keep that in mind. So one that I'll look at right here, because we're going to walk you through it, is I've created a custom tag dictionary to apply rules. But what I want to kind of show you, okay, is that my tag dictionary will actually apply other tag dictionary components, right? So in this example, I want to create a tag for space temp, right? I want to go find all of the space temps. And so a lot of customers have a lot of, in their portfolio, they have several different contractors and several different manufacturers of the equipment, and all of the points are named differently. And so here I can show you how you can create a rule that will allow us to create essentially a rule that will go and find all of the space temp names. So I've created a rule called space temp. It is an AND rule. So if you look at the tag dictionary palette, oops, right there at the bottom, I've created a rule that is an AND rule. That's where I start because I'm going to have conditions. I need all of them to be true, okay? But what I'm going to do is I'm going to actually break down that AND rule into a condition where there's an OR. So I have to have this has to be true. It has to be of type numeric control point. And it has to be one of these. So I have an OR condition, which you can get down here in the conditions. So the and is I have to have two. I have to have both true. So if I don't have anything out of the or, that will come back false, then this will actually be false and it won't apply a tag. So it has to be a numeric control point. And then I did this longhand. So just to kind of show you how it's done, and I'll kind of start here. I say that if the name, the point name is room temperature, spelled out room temperature, or it's room temp, or it's space temp, or it's space TMP, right? You get the idea? I can put in a list of different names that I want this to apply. It's only going to be one, but it has to be one of these. There's another thing that you can do, and that is a wildcard, right? I can say, hey, the name is like, and then I did two wildcards. I did the star, or the dot star, and a dot star, which says that name has to contain room temp in it somewhere, right? So these are very specific. It equals. This is, hey, I'm looking for something inside of a name that would resemble room temp. Okay, so keep that in mind on how you build out these conditions. And I'll show you, we're going to test this in a second here. So actually, let's go test it now. And so what I'll do is I'll come over here to my examples, actually to my network here. And I'll open up this test. Ignore the display. So here's this rule, right? We're going to look at this space temp rule. I'll kind of tidy it up here. Okay. So we're looking for a control point and a numeric control point. It could be read or write, and it has to have one of these criteria, right? Space temp, room temp, what have you. So if I go and look at this point, which is called test point, right? And I go and edit the actual tags. There are no direct tags, and there are no implied tags that I have in my rule. So if you look at my rule, the tags that I want to imply is a group tag definition, which is this temp sensor group, which will put the temp and the sensor tag. Okay. So if we go back to test, when we look at the tags, nothing is direct, nothing is implied because we don't fall within that rule yet. It's a numeric point, that's true, but it doesn't have any of the names that we had. So I could go ahead and, you know, add a sensor tag, but I don't want to, right? I want it to be implied. I want it to be done automatically. So if I rename this, and we rename it to, let's do space temp. Now, if we go and look at this and we edit the tags, down at the bottom, the magic happens. It has automatically implied the temp sensor group, which has the temp and the sensor as individual tags. So I just went from something where I had to go in and create a point, right? If I want to come over here and say new numeric writable, and we call this space TMP, right? That's one of my rules. Space, oh, see, lowercase. Need to change that for mine. Case sensitive. Now we go and do edit rules, and we can see that it implied the temp sensor, temp and sensor, okay? So this will save tons of time. It's well worth the time engineering the rule because it will do it automatically. And what's really cool, if you think about it, if you go into your tag services, all I have to do is copy this dictionary, right? And then paste it into any JACE or any supervisor, and then those rules are automatically implied. Okay, so it's done in real time at the time of the point, right? So that's the power of these rules. So I won't spend any more time other than let me show you a couple other ones that I was working on. So one of the things that I'll do, and you'll see in my station, I like to attach a PX page to a folder, so I can visually see over on my right side when you see my examples that these things have PX pages attached to them, right? So I have a view, which I did wrong, I'll admit that, and then I have a dashboard, which I did right. And so where I want to show you this is this condition, if I just look at the names, and I had that condition of or, right, it would evaluate every point in Niagara to come up with that. So here I wanted to actually have it look for this numeric point, and so we'll only look at the numeric points and then evaluate the name. So you do want to create a condition that will fail fast, right? So here in my condition of or, I just said, hey, it has to have one of these things included in it, right? A view, a capital view, or a capital PX, which means it's going to actually look at every single point within my Niagara database. Probably not so good. So what I did on the dashboard minutes before I joined the call is I said, well, I should have a is type, right? I should go and look to see if it's an object type folder. Then that's my methodology. Then I can start to look for it if it has dash or dashboard or the dashboard in its name. So this is a better rule because it gives it some scope. And you'll see in the palette, you have all kinds of ways of saying, hey, it has to be a device. It has to be on the backnet network. So anything that you build in your rule to eliminate and fail fast is a good thing, because then it won't go and chug through the entire database implying those names, okay? So with that, that's tagging. What I'm going to do now is show you some of the benefits that you can do with tagging, right? So in that one example we did on the screen, right? If we look at this now, there are times you do have to direct tag, okay? So in this instance, I tagged the city and the state onto that particular JACE, right? And so if you come down here to North Carolina and you look at the Raleigh JACE, right, you'll see that that's tagged differently, North Carolina and Raleigh. So having those tags in place gave me the ability to do that hierarchy. Super easy, and I showed you that in the screen before. So again, that's a benefit of the tags. So let's take a look at analytics and how tagging works. So this is asking you to drink from a fire hydrant. So lots of information here. I'm not going to get into a lot of depth of the analytics because we'll save that one for another Tridium talk, but the tagging is what I want you to start to look at, how to create rules. So once you look at analytics, essentially what happens is you can actually do some pretty cool things with analytics that make life living in Niagara pretty nice for productivity. So I can actually create algorithms and rules for the algorithms, and then copy and paste or redeploy in templates over and over, because they're genericized. The data is looking for a tag. And so here I have an analytic point, and I'm telling it to do something, right? So these, if you go into my analytics palette, down here in the bottom are actual analytic proxy points. These can be extremely powerful, and you'll see how I'm using them in my demonstration. So this will let me actually put an answer to an algorithm, an analytic algorithm, or a historical search into a point so that I can then visualize it, okay? So one of the first things you need to learn is that in analytics, you have to tell it where to look for the data, right? So this is the ORD. It's looking at the energy meter, which is down here. So I have this energy meter that it's going to look for. It's going to look for data that is tagged with the haystack energy tag. And then what I'm going to do is I'm going to ask it for a result. I'm going to say, give me today's numbers. But I'm going to have to tell it what to do with today, right? If my energy meter is sampling every 15 minutes, I need to be able to add them all up. So I'm asking it to sum it all up, and then it gives me a result. It gives me about 1,200 kilowatt hours, okay? So if I look at this, you'll see that I can ask the analytics, give me the max reading for the day, or actually the max reading for yesterday, give me the average, give me the minimum, the mode, the first, the last, how many are in the data set, right? So you get the idea. And it's as simple as saying where to look, what to look for, how much, and what you want to do with it. Okay? So that is some basics with algorithms or with analytics using these proxy, analytic proxy points. So let's take a look at a analytic that will, this is one that's out of the palette. So if you look at some of the samples, we give you a sample library of these algorithms, and one of them is down here is, you know, has your electricity exceeded the month, okay, of your target. So what I've done is I've created a visualization of how that algorithm works, just to kind of give you an idea. And what I did is I'm not going after histories. So I'll show you the analytic, or the exceeds target actual is actually going after a history. But I'm going after a tag that's tied to one specific point on this sheet. So what I've done is I learned by doing this, because analytics run across the whole station, every folder, every device. And so here I'm directing it only to look at this folder. So now I know where all my variables are, okay? And I've tagged them HS energy, HS area, the target, and then I have outside temp. And then I have these proxies that are running the algorithm. So here I'm saying, look at that slot. So I'm going right back to exceeds target. And then I'm running this algorithm that's going to come back true or false. Does the target exceed, or does the current month's energy exceed the target? Okay, that's all that algorithm does. Okay, so let's take a look at how that works then in reality. So here I've built a little simulation bar. So what I can do is I can actually control the monthly energy intake. So my targets are set. My target monthly is 70,000 kilowatt hours. Right now I've consumed 21,800. So if I exceed 70, right, we're gonna blow out the target. We're gonna be over target. We're gonna exceed it. And so that algorithm that's running comes back true or false. If it's true, we've exceeded. If it's false, we're good to go. We're under. And then I visualize it here. So just to show you, since I use these proxy points, right, I can actually start to do some visualization and math that you're seeing up on the screen, which is I can say, all right, the current minus the target. So I know that I'm 23,000 kilowatt hours over. That's about 33% of an overage. And then I can take the two costs, right? If I know that it's like 15 cents, or ooh, I'm doing 45 cents. Let's take it down to 25 cents a kilowatt hour. We can calculate the costs that are associated with that. And of course, this morning when I wired that up, I forgot to wire that up. So it's changing it, but not running it through my calculation. But you get the idea, right? So that $23,000 is the difference between the two. And that would be the overage that I achieved in this month's energy. Now, what I did down here is I actually created the algorithm, and I put some of the variables on the screen so that as I was learning, I could actually see how the algorithm was performing in the different conditions. So the algorithm takes an account for square footage. So this algorithm actually uses about 5 analytic points. It brings in a target, monthly target. Since I'm doing 2 algorithms, I'm doing a yearly algorithm, and I'm doing a monthly algorithm. So if I grab my yearly algorithm and bring it down to 70, I'm going to blow out the year as well. And you'll see that will trigger off in the same way. So the other thing that your analytics, you actually control when you want them to run or how often you run. So you actually create a pull schedule. Okay, so boom, I've exceeded the year. So it shows me that I've done $5,000, pretty much, or about $6,000 cost difference over the year. Okay, difference of 23,000 kilowatt hours. So there's 2 equations running. In this screen, I'm using 5 analytic points: the targets, the area, the energy, and the outside temperature. Okay, so those are just some simple things that you can do using the algorithms that we supply to you. I'm going to reset everything back up, make everything go green. So if you look at actual, right, if you look at this wire sheet, I don't have any local points. It's actually doing it from the energy meter. So here I'm going to the energy meter, which has a 5-year history of every 15 minutes. So these are actually built out comparing against an actual energy meter. And I did that just to make sure I understood how that was working. So cool things you can do, right, with the dashboards is I can actually show you how our progress is this week. I can see that I'm lower than last week. I can see that this was last week, so you can see obviously they're lower. Last week I was actually lower than the previous week. So 2 weeks ago I was actually higher. So you can start to see these trends, right, and build those out. I did do a comparison of monthly. This was designed for an enterprise. So they wanted just to see a quick comparison on a dashboard of how they were progressing. So the brown is last year. So you can see that we're way under, well, it's the beginning of the month, right? For June. May, we were actually under last year's consumption, last May. So we get that history, and you can see in January, we were actually over the previous year's consumption there. Okay, so some interesting, real quick analytics to kind of give you year to date, week to date, you know, build out a dashboard, right, that shows how the gas, electric, and water, even solar, is being compared to a building. So a lot of buildings that do put solar, they like to have these dashboards running in the lobby showing you how much the solar is offsetting. So that gives you some capabilities. The last one I'll kind of show you is, here's a temperature, essentially an analytic that tells you whether the temperature is comfortable. And I've got 2 versions. I've got an ASHRAE version and my version. My version, I actually take in account CO2. So if the CO2 of the room gets out of bounds, right? When you look at my algorithm, right? The CO2 is saying, hey, I'm looking for that tag CO2. Here's the high, do a comparison, come back and say whether it's higher, right? Is this 1,000 over 800? Yes. So I know I have a condition where my comfort is poor in that room. If somebody comes over here and, you know, overrides at the set point to 81, I'll just do it for a minute. I'm also tracking, you know, how many times they override it. And now we actually error out the ASHRAE temperature. So 81's too hot, right? And somebody's overridden it 84 times and it's been in that state 2 hours and 52 minutes, right? So again, these are just some of the things that you can do with the algorithms, and you'll see that I tell it to look at the local ORD, which is pointing right back at itself. I run this algorithm temp check. I get a true false that the temperature falls in the range, and then I can do the rest of the visualization. Okay, one last one just to kind of show you some really cool things that the analytics can also do, and then we'll open it up for Q&A. Here's working on a fault detection algorithm for a rooftop unit, right? So the rooftop this is probably all you would see on a dashboard. The second row is a little more detailed than you probably want, but I was getting a little carried away on the UI. So if I have essentially my filters start to clog, right, I can actually do algorithms that say, hey, that's a dirty filter and you should probably do maintenance, right? If it's really bad, you need to replace it, right? So we can actually look at the sensor on the front and back of that filter and actually see the draw. So this isn't time, this is actually watching the static pressure. If I have a belt that breaks on a rooftop unit, I could then indicate that there's a failure. So here I show it in this little line. You'll see here that I can show it on a grid to say, hey, this is kind of like a bingo board that said the power's failed, the belt broke. If I have some vibrations, I can show that up in maintenance. Necessarily, not necessarily a problem, but I want to have somebody check it. The refrigerant's low, or we lose power on the compressor, lose power on the actual fan. And so keep in mind the sensors that I would be using here is I would be watching amps on the motor, right? The amps are going to be higher when it's dragging a belt than it is when it's not. So you have to think with fault detection on what you're trying to achieve in those detections. So that's a little bit about tagging and how tagging leads to the ability to do some analytics. We'll do a session, a Tridium talk specifically on analytics where we can actually tear apart like the comfort algorithm, but we wanted to show you how tagging, what was happening is I would go out and show analytics to groups, and what I'd find is I'd say, hey, how many people tag? And not very many people put up their hands. And I'm like, well, the two go hand in hand. So this was to kind of get you thinking about tag rules and using those tag rules to tag your information. And then this is kind of showing you some of the benefits that once you start tagging, you can start to do some pretty interesting algorithms to help your customers out and save them money. So with that, Eric is here, and he's probably been answering questions as we go through. We can actually start to look at some of the main questions here, see if we've got any up here. So there's a bunch answered. So if you're watching those, he's answering them through the chat. So within analytics, how do you roll up the last 2 weeks? Okay, that one's an easy one. Let me show you. I'll go to, I have a weekly thing here. So this is my old UI, so please ignore that. So how I did this is I'm using essentially a time range of this week, right? Give me this week, sum it all up. If I want to give it a specific week, right? So we use key names like this week and last week, but here's one that's actually set by a range. So from this week, go back 14 days and give me 7 days worth of data, right? Or you could say go back 2 weeks, right? Or go back 0 weeks and give me 2 weeks of data. So you can create these ranges on how much data you want to actually manipulate, okay? Can we get the station along with the video? So yes, so the video will be posted. The station, I need about another week. I'm doing the London forum. So this station with all the new UI, I'm diligently doing. So you can see this is the new UI, this is the old UI. So as soon as I get all that transferred out, we will post the station. Did you put together PX graphics that you just showed for fault detection? Yes, all of these displays, all of these components I built using algorithms that we brainstormed in the office. Said, how would I have a rooftop controller in my cube. And so I was like, how would I find problems with this rooftop? And so we looked at what sensors I can hook up to that controller, and we built that model based on what sensors we could add to an existing older rooftop that doesn't give us those diagnostics. So I will let Eric talk about 4.0 on that. And yes, this station will be posted. I just need about 2 weeks. So it will post after the video. And again, you can find where these post by going to the resources. Go to tridium.com resources or events. So you'll see all those Tridium talks. It will be posted up here with a description. We'll have the playback. And then once the station is done, we'll add that. And then the questions and answers that we're answering now will also be posted. So we'll give you the whole gambit of stuff that we're talking about today. So with that, I will end the presentation. I want to thank you for attending. I know that's a busy schedule that you have. So we know that when you hit these webinars that you're able to grab a little bit of information. That's why we're keeping them to about a half an hour where we can kind of talk about a topic and then we can dig deeper in a later one. So keep an eye out for additional Tridium topics, and we will talk to you again next time. Thank you for coming. Thank you for listening, watching.